Hi everyone, thanks for dropping by my YouTube channel today, where I'll be doing a quick guide to configuring a DeviceNet slave in Beckhoff's TwinCAT 3 system using an EL6752 Master slave terminal. Before we proceed, I wanted to let you know that the intent of this presentation is really to document the steps that I took to configure a Beckhoff EL6752, a single-channel DeviceNet communication interface with a third-party I/O module. This is really meant to be a guide only, and any method you use certainly may be more appropriate, work better for you. This is what I use, it worked for me, and I wanted to document it so that I have it in case I need that kind of information in the future. So I did this in November 2021. I used a Windows 10 computer. It had TwinCAT 3 on it. And I also used an EDS, an electronic data sheet, for the third-party DeviceNet module that I used, the one that I'll be connecting to. On the hardware side, as I mentioned, I used a Windows 10 PC. It has a dedicated Intel brand network port, network connector on it, and that is connected directly to a Beckhoff EK1100 module. On that EK1100, there's also a number of different terminals which are not used in this example, so we won't see them, but they're there nonetheless. And those modules include the EL6752, which is, again, the DeviceNet communication terminal. I also used a DeviceNet slave. In this case, it's a Crevis brand CT-C134 IO module, 16 digital inputs and 16 digital outputs. I also had to use a 24-volt power supply to power everything, the Beckhoff EK1100 along with all the slices on it, and the EL6752. And the Crevis CT-C134 was powered from that same item. I built myself a 5-conductor DeviceNet cable with the Phoenix contact connectors on it, which is pretty standard for DeviceNet. Nothing special there. It's just mine was 18 inches long. I did not need it to be very long. So to get yourself started, you need to make certain that your PC has a fully functional copy of TwinCAT 3 on it. You can download this for free from Beckhoff themselves, beckhoff.com. Just make sure that you can load and save some TwinCAT files. Make certain that your TwinCAT is properly configured with the real-time Ethernet compatible device. That means your network port on your computer, the one I previously mentioned had to be an Intel port, is configured in TwinCAT and is connected to your EK1100. And you need to download from the device OEM the appropriate EDS file. That file needs to match the DeviceNET Remote IO device you plan on connecting to. In my case, I used a Crevis CT-C134 module, but you'll need to research your own device and download its own EDS file. Those files really should be available from the OEM website, and they should be free. Basically, they're just text files. So, I say that, a typical EDS file looks like this. We have a file descriptor, a device descriptor, like for example the company name, general purpose I/O, the name of it, the product name and catalog number, even a bit of a link to a PDF. And there's also I/O info for the actual I/Os on the module. I highlighted in blue two names here, produce connection and consume connection. Produce connection, consume connection. I noted those because when we get to page 17 later on down in this presentation, we'll see that these names pop up and this is where they came from. Just be aware of that. They come from the EDS file. So to get started with all this, start TwinCAT and create a new solution. On startup, you'll be asked to, if you want to open a solution or create a new one, go ahead and create a new one if that's what you want to do, and give it a name of your choice. In my case, I gave it DeviceNet _test_02 and save it in a location of your choice on your PC. Just remember where it is so you can retrieve it in the future. You'll need to add a standard PLC project to it. So click on PLC, add a standard PLC project to the solution, and name it. In my case, again, I named it DeviceNet _test_02 PLC. That's the name you'll see in the device tree once it's installed. Once everything is up and going there, click on the blue charm icon at the top, and that will ask you if you want to switch your system to config mode. So go ahead and do that. Once you're in config mode, you'll have the scan option wherever it's applicable. And that's what we're targeting here, being able to scan for certain devices on the hardware side. Once you have everything in place and you're in config mode, we can go ahead and scan for I/O devices. You can do that by right-clicking on devices and select scan. You'll see the little wand there, or up in the menu bar up above, you'll see the scan button. If you're in config mode, you'll see the scan come up and you'll be able to use it. Once you click on that, you'll get this notice saying that not all types of devices can be found automatically. Just remember that and click OK. That appears every single time. So if everything in TwinCAT is set correctly, and I go back to your real-time Ethernet devices, the scan should find the EK1100 unit you're connected to. It'll look something like this with device 2 EtherCAT, Ethernet 2 TwinCAT. If that's all correct, click on OK, and you'll be asked to scan for boxes. Respond OK to that. It'll report that some I/O devices are found, and specifically the EL6752, and if that's all correct, click Yes. And the scan should then identify that you have an EL6752 connected to the EK1100 stack. So it's going to ask you to set the baud rate for it. The baud rate needs to be set to whatever you have so that it matches your own device. So you need to look at the switches on your device or the configuration method on your device and see what baud rate it's set to. In my case, mine was set to 500K, so I went ahead and set that to 500K, and I clicked OK. And the MAC ID search was immediately started. So a scan for the MAC ID was started automatically. And in my case, it wound up finding MAC ID 4. It reported back a MAC ID 4. And that is correct for me because my Crevis CT-C134, the switches on it were set to number 4. So I clicked OK. It asked me if I wanted to activate free run, and I said yes. So now let's have a look at our updated Solution Explorer tree. We see that we have the PLC in place. We have our original project name. We have the PLC in place with the name we gave it. And we have two devices that were found during the scan. Device number 1, which is down here, is the EL6752. And device number 2, which is the EK1100. And if I were to click on this, it would show all the other devices I have on there. But as I previously mentioned, they don't have a play in this presentation, so I'm not going to go down that road. So if this is looking like you expect it to, all is good. Go ahead and save it. Now's a good time to save it. Now it's time to add a DeviceNET Node to our system. So if we right-click on device 1, the EL6752, you get the option to add a new item, and that will open up this insert dialog box. If you scroll to the very bottom of that box, you'll see miscellaneous, and if you expand the plus sign, DeviceNET Node will pop up. Click on that once, give it a new name. In my case, I gave it Crevis CT-C134. I responded OK, and that caused the system to go looking for the EDS file. So I browsed the computer over to where my EDS file is located, and I highlighted it to put it in the file name box here, and I said open. Once I did that, the Crevis CT-134 device node was installed in my device tree, and we noticed for the first time that my inputs are named produce connections and my outputs are named consume connections. If you recall, if we go back to page 6 of this presentation, the names produce connections and consume connections were given by the EDS file for the Crevis CT-134. So everything here is looking very nice. I have inputs and I have outputs. So now we need to set the MAC ID in TwinCAT. So if you go back to the Crevis CT-134, you highlight it or double click it, that will open it up in our work area. And you go to the DeviceNET Node tab, you'll see the very first item is MAC ID. For me, on my system, the switches were set to a 4, so I entered 4 here. This was originally a 1, I changed it to a 4. And that sets the MAC ID in TwinCAT to 4. So now, whenever we try to communicate with my unit, we'll use MAC ID number 4. So that's all good. I then went ahead and created a GVL. I named it DeviceNet_GVL. In there, I created a couple of arrays of Booleans. One to read the CT-C134 digital inputs, and one to allow me to write to the CT-134 digital outputs. So it was an array of Booleans. DeviceNet underscore CT-134 underscore in, and I used AT%I. That was for the inputs. For the outputs, I did array of Boolean DeviceNet CT-134 underscore out, and I used AT%Q. So you see that here in my global variables. The next thing I did is I made a link to my CT-134 input variables. So this is a little bit tricky and there's a lot of work to do here, but it's very repetitious. So for my module, I had 15 input connections and 15 output connections. So my array was 15 units long. And for every one of these input connections, I had to double click on it to open up the variable file on it. And then I clicked on link to, which opened up this attach variable connection window. And from there, I selected the appropriate variable from my GVL. So in my case, it was AB DeviceNet CT-134 in. So I did that for every one of these variables. And I did the same thing for the output side, where I clicked on every one of these output consume connections, and I then linked to an actual variable in my global variable list. So that's how I connected the hardware side in the remote I/O to the software side in my web visualization. In my main file, I created some variables, although I used very few of them in actuality, but I created a very small amount of code to connect the remote I/O inputs and outputs to the web visu's inputs and outputs, which is what we'll see in a second here. I did create the visualization that had 16 digital inputs. They were lamps, and they're used to display the input bits of the CT-134 on the web visu. And I created 16 digital output switches in the web visu to drive the CT-134 output bits. I also added a CT-134 graphic with LEDs on it just for fun. So we can look at that now. The actual visualization is here. As you see, we have the 16 lamps. I've labeled them all. And they connect directly to the 16 inputs onto the Crevis CT-134. That's what the unit looks like in real life right here. I also used 16 visualization switches and connected those with variables to the 16 digital output bits on the actual CT-C134 module, the hardware itself. I added an image of the Crevis CT-134 and gave it some LEDs on it as well, so we'll see that in action when we get to the visualization. So let's go to the visualization now, and when we do, we'll see our 16 lamps. I've labeled them digital input 0 through digital inputs 15, which is what they're called on the Crevis itself, and 16 switches. I've labeled them D0 through D015, which is what they're labeled also on the CT-C134. So when I click on a digital output, we see that the green light goes on. We also see a green light come on here. And because I have one wire that goes from digital output 0 to digital input 0, we see that digital input 0, the lamp also came on, and we saw it come on here. So if I toggle that on and off, we see that they both work. So that's the visualization at work here. I did not run wires from each and every one of these 16 switches over to the 16 lamps, but I did have the switches in place so that if I actuate those, we see the LEDs come on the visualization of the module itself. So that's all functional. If I had taken the time to run the 16 wires, these could all be made to come on as well. So I've tested all of the outputs, inputs, and everything works fine. So I'm quite happy with that. So there we have it. We have the visualization working correctly to drive the outputs on the module, and the output of the module actually drives the input of the module, and we see the lights come on at both locations. So I want to thank you all for taking the time to watch this video right to the end. Please feel free to leave questions or comments in the comments section below. If you found that this video has value to you, please take a few moments to leave a thumbs up or like for this video. And I also urge you to subscribe to my channel. I would appreciate that very much. If you're interested, you can buy this very Crevis CT-134 on eBay, if it's still listed, depending on the date you watch this video. So browse over to eBay and do a search for CT-134 Crevis, and most probably you'll find it there. Thanks everyone. Bye-bye.